So we talked about these libraries. If you have a portable executable file and it has imports, these are linked to the main exe if you're going to use library functions. There are three ways to do it. Static linking is the simplest and easiest to understand and almost never used by Windows because it wastes RAM and slows down your programs. Linux often uses it because they cannot count on you of having all the libraries there. This is where you link, if I have a program and I use a library, I add the library to the program and now the whole program is bigger. It contains all the libraries. I remember I used to do something like this when I did a lot of legal documents in Microsoft Word. You can save a Word file, but if you don't save the fonts with it, if a person at the other end opens it and they don't have that font, it won't come out exactly the same. So you can use an optional save that saves the document and all the fonts, so it gets bigger, but then I know when I email it to the printer and they print 1,000,000 of them, it's exactly the same. And it's the same thing here. So you put the whole library in the file, now it can run without accessing anything else. That's done in Linux. It's almost never done in Windows because it would make all your files longer to load, use up more RAM and everything else. Instead, for efficiency, Windows use dynamic linking, which is the most dangerous and unsanitary, but it makes things load faster and preserves RAM. Runtime linking is another option, not used in normal programs, but commonly used in malware, where it connects to a library while it's running. I remember there was something like this in Microsoft Office 2003, I think. You would load Microsoft Office, and then you'd click File something, and if certain options were not really loaded yet, when you chose certain options in the menu, it would ask for the installer disk and install more of the program. They only loaded like the most common features by default, which was kind of screwy. Anyway, this will call libraries while you're running. And this is the kind of thing you see in Windows, and as you see in every version of Windows, primarily Windows 98, but it's still happening. The program can't start because msvcr100d.dil is missing, a missing DIL, and then you can hunt the internet and download fishy DIL files from suspicious sites to try to get this junk working. But those DILs are the libraries you need. And if you don't have the library, the program won't run. So the PE header lists every library that will be loaded, and you can just look at the names of the libraries and get a pretty clear idea of what it's doing. If it's uploading URL download to file, well, then obviously this thing uses the internet and downloads something, and that's a clue. So there's a tool called Dependency Walker, which is here to help you resolve things like bad DILs for developers, and we use it too. So services.exe, a Microsoft executable that loads services that will run in the background, uses all these DILs, crypt-based for cryptography and all different DILs. That's what you'll typically find with a normal real program. It uses a lot of libraries. Here's a malicious file, services.ex_, pretending to be the real services, and you can easily tell the difference. It loads almost nothing. Because it's malware, it doesn't really do a lot. It does one simple thing, and just tries to look like services, so if people open Task Manager, and they'll see names that look like Windows. Another thing I've seen is NTDLLL, because the real one is NTDLL, so the malware is NTDLLL, just so it looks pretty good in the list. So in Dependency Walker, you open this thing up, and up here you see the imports, and here you see the exports. And we're going to talk about them. All right. So here's common DILs. You should know what they do. Kernel 32 lets you access the hardware. This is a very common DIL. If you are a Windows program, you run in what's called user land. Kernel land is a special high privilege kind of executable that actually gets access to all the machine language instructions in the processor. The processor restricts access to some of the instructions, and user land programs cannot use them. So if you want to send an electrical signal out the wire and print something, and you are a program someone's writing in C++ over here, you can't. You are not authorized to touch the hardware. All you can do is ask a Windows routine, please send something to the printer, which will then check the driver, which runs in kernel land, but you are not authorized to touch the printer. You can only ask the driver to please print this for me and let me know if you actually succeeded. And that kernel 32 gets you in there. Advanced API lets you see things like the registry. User 32 has the user interface components like buttons and scroll bars. And GDI has functions for displaying graphics. NTDIL is the interface to the kernel. Normal executables do not load NTDIL. they load kernel 32. Now there's a fundamental rule in Microsoft naming, which everything is named the opposite of what it should be. So kernel 32 is not the kernel, and it does not run in kernel mode. It is the component that is the furthest from the kernel. It is the program interface to the kernel, which then loads ntdil, which also doesn't run in the kernel, which then goes to the kernel. So you can always remember Microsoft names that way, they're the opposite of what they should be. WSOC and WS2 are the famous WinSock. There used to be a place called Two Cows, the ultimate selection of WinSock software. This is the way Windows does networking. And so these are networking DLLs. These are low-level DLLs. In Python, I use a lot of this where you have to open a socket by port number and IP address and then send data byte by byte. And these have been around forever, using low-level native connection to network sockets, but they're not that common anymore. Most people would rather use WinINet that has one command that will connect to a server and download a file. And rather than making me handle every exchange bit by bit myself, it does it all for me. But you can use either of these. It's just unnecessarily difficult to get anything done with the socket library. It'd be easier to use these high-level libraries that do more of it for you. So DLLs export functions. An exported function means I've exported a handle so you can enter my code. Now normally, if I'm writing code, like in C, I have a main routine, and that's the only place you're supposed to start. So I only export one way to come in. But if I'm a library with like an ntdil or a WinINet, I have 50 functions, so there are 50 possible ways you might want to enter. Call this function, call that function. So a DLL will have a lot of exports. An exe will have a lot of imports, which is functions it uses that are in libraries. That's typically how you tell the difference. They're both listed in the header. So here's notepad.exe. I'm looking at it in PE view that lets you see the header. And you can see it's got an import address table and imports all these things. Delete file, create file mapping, unlock a file, get file information, you know, all the things it has to do to save a text file. And so those are library functions it uses, and those are imports. There aren't any exports showing up here. There's just going to be one entry point, and I don't even think the default one shows up as an export. Here's advanced API.dil. That's got a ton of exports. All these functions, this is just the A's, are things included in that library. So you can add access allowed to an object and so on. Many, many exports. And there is an import table, but there's not much in it. Here's iTunes setup. An installer to put the iTunes library on your machine. There's something I had on my machine to play with. And it's got an import address table down here, but no exports. Because there's only one way in, you only start it from there's no reason to start except from the main. It just does one thing, installs iTunes. So a keylogger might import user32.dil so it can have an interface, and then use the function setWindowsHook, which is a way to catch key presses. Then it would export keylog process and register hotkey to define a special keystroke. Here's a packed program. A packed program has very few functions. It really doesn't seem like it does anything at all because all you're seeing is the unpacker. So all it does is unpack the file. Then inside there is all the stuff you can't see while it's packed that has another header, which will, of course, import more. So here's the text, I say, is where the instructions for the CPU to execute. Our data is imports and exports. Data is global data. And resource is extra data you use, like strings to put in help messages and icons. Here's PE view is one tool that makes it easy to see what's inside here. Lets you see the header and navigate through it, and you'll use it in the projects. By the way, there's a time date stamp right here. You see time date stamp 2009-7. This tells you when it was compiled. This is a big deal. The Mandiant reports on malware always talk about this. They use these to determine when people wrote it. And this is how they catch the CIA and the NSA. They call them the equation group. The NSA, in my opinion, has terrible OPSEC. All their stuff is blindingly obvious to see. They always name their thing something like Hunky Peanut, and they always make it capitals. It's always two-word. It's always a joke. And you can see that just screaming these military code names, and they do it between 9 and 5 Washington time, and they don't alter their clocks. And the Russians are great at the Kaspersky antivirus, totally catches them, and they don't call them the NSA, they call them the equation group, and they have a graph of the compile times of the executables showing that they do it all between 9 and 5 in Washington. Other people do it between 9 to 5 in China or 9 to 5 in Russia. Those are the three main contenders, and you can tell who they are. It's amazing how they don't hide that number. Anyway, by the way, sometimes it's wrong. Delphi, the compiler, does not store it correctly. It's always 1992 if you may write your program Delphi, but I don't know how many people are writing their code in Delphi. So you've got virtual size and size of raw data. These are usually the same, but if you have a packed executable, they're not. That's one way to detect them. So here's a not packed thing, and the virtual size is, now wait a minute, I went virtual size and size of raw data. Yeah, is 1,000 here. Virtual size is A68C, and the size of raw data is A800, so they're about the same. That's not packed, but here's an example of things that are packed. A virtual size is big, and the size of raw data is something very different, like 0. All right, because since it's packed, the header of the packer is not really telling you all the information about the size of the file. Anyway, Resource Hacker lets you wander through this. It's a Windows tool people use to like customize games and stuff, lets you play with the icons and images. It's not terribly important to us, but it does let you see all the icons and such. Here's all the different icons for calc, showing how apparently it has some kind of graphic where it dissolves and comes back, so it has to store all these slightly degraded images of calculator. All right, I've got a few more iClickers, and I think that's the end of it. That is the end of it. Good, because otherwise everyone's going to fall asleep. I'll just say a word about the projects so you know how to move ahead. So which technique makes an executable large? Quit at 25. All right. That is static linking. You're putting whole copies of libraries in there, making the file bigger. All right. I say, there we go. All right, what's the most common technique for normal executable files? Quitting at 25. All right, Windows uses dynamic linking, and it does not pack stuff by default. That's what normal things do. Static, not runtime linking, that is strange, where you'd actually, it uses what's called dynamic linking, where you list all the DLLs in the header, and when it loads, it connects them to the libraries. The point is, most of the time, those libraries are already loaded in RAM because some other program's already using them, so you don't need to reload them. And that's why it makes things faster and makes them consume less memory. It's also unsanitary because many programs are using the same library in RAM, so if one of them modifies it, it can affect them all. But it is the way the whole design of Windows was originally designed to ignore malicious activity. Until 2002's Microsoft's official policy is there aren't that many hackers. It's a waste of time to do anything about it. What we are doing is making code for business people. We're an honest user trying to get their job done, and just making honest mistakes should succeed, and we're not going to worry about people who think of exotic attacks. And that was their fundamental design philosophy, which made a lot of money for a long time. And now they're slowly reforming, and really they've gone quite far at reforming, but the fundamental principles of it remain the same. This is there for efficiency, and it certainly is the case that people buy cheap hardware without enough RAM and try to use it for a long time, and they really would rather have an operating system that doesn't waste RAM compared to one that has some esoteric security features. Anyway, so which library is required for malware that uses FTP? All right. I'll quit at 25. and you'd probably want to use WinINet for that. You doing your FTP handshakes all by yourself would really be a drag. FTP is pretty complicated. In principle, you could do it with WSOC, but it would be really a drag and make your malware much bigger. Which one of these is required for malware that has pop-up boxes with buttons? Like, you know, ransomware that's going to pop up a box saying, I just encrypted your files. Go pay me at this Bitcoin address. All right, that's user 32 for user interface items like that. Good. All right. And which one of these is not normally linked and would make you suspect that that stuff is malware? Quit at 25. All right, and that's ntdil. You don't normally call ntdil. Instead, you call kernel32, which calls ntdil on your behalf. All right, now I'm going to look and see you've got the most of those right, but before that, I want to make sure you're ready to do the first couple of projects. So let me go down and see what we got here. Yeah, basic static and basic dynamic techniques. There's a few things you have to do to get started. You're going to need a virtual machine to work with. If you have any kind of Windows in a virtual machine, you can use it. If you want to use my stuff, I did these things in a Server 2008 machine. You'll find it here. Now, to get to that page, you need a name and password, which I'm going to write up here. I won't say it out loud because of the recording. This is the username, and this is the password. Make a note of that. If you forget it somehow, you can always email me or something. But that's what you need to download the virtual machines. You'll need some virtualization product, either VMware Player or VMware Fusion if you're on a Mac, or VirtualBox if it runs better on your system or you prefer it. All of them are fine. For this class, 126, you need Kali and Windows Server 2008. You should get Kali directly from the Kali links, and Windows Server 2008, you can get it here for the VMware version. If you're using VirtualBox, download it in 2 files here and then import it in. It's a different format, but it amounts to the same thing. If you've already got the Windows 2008 machine from some of my other classes, you can just use it. That's fine. It's all the same. This is an old version of Windows without the patches, without any antivirus. Whatever you need, you have to have no antivirus on it, because this malware is only slightly modified from real malware, and it will set antivirus off like crazy. So you have to get a virtual machine of some sort running. And then you have to download the textbook labs. You're going to have to download a file all full of malware. So if you download this on a machine that is, this is a great image, by the way, I should use that one. So you can download this thing here. You can download them directly or in a 7-zip file. An encrypted 7-zip file, by the way, is how most professionals trade malware around. If you just encrypt it with the password malware, it will go through all the antivirus. You can email it and everything, which is kind of evil, but that's the way it is. So if you're working on a machine with antivirus, you can download it here, but you won't be able to unzip it until you put it on a machine with no antivirus. And you're going to need these files, so you put them in your virtual machine is where you should put them. Yeah?
All that is already ready in the machines that's in the lab?
The server is on there, but the malware is not on it, but you can easily do that. Yeah. Yeah, the machines in the lab have a copy of Kali and Server 2008 on them, and they have the 7-zip files, so you can extract them into a folder and make your own clean ones. Yeah. All right.
So which one?
Either one, they're both fine. This is the self-extracting archive, and this is the encrypted file. This is the one that will not set off antivirus if you download it. But to use it, you're going to have to unzip it, and you'll have to do that inside your virtual machine. Or in some machine that has no antivirus on it at all, because it will freak out and block all this stuff, because that stuff is malicious. Well, it looks malicious. All right. So then you practice a few of these techniques. Here's the basic static techniques. You're going to get a file, download the lab files, send it up to VirusTotal, and analyze it there. Look at it in PE view so you can see its header. Look at it in PEID. Since it's not packed, PEID can tell what it is. It was written in Visual C++. And then you run strings on it. You can run strings on Linux, or you can download strings from here, from Mark Rasinovich, or you can use other things like bin text, find the strings. And you'll see that this thing has nice readable strings. Here's the path to a file it's going to create on the system. Here's some calls it makes, so it's obviously does something having to do with saving a file. It has file, uses Microsoft libraries to save a file and then saves a file in this location. And you can see other things down here in the strings like exec and sleep, and then there's an IP address here which you turn in to show that you actually got it. And then dependency walker. You just go through these tools we were talking about. Here you can see the imports and exports. And see the kernel 32 imports and exports here. And this is all in your textbook. They go through this step by step, explaining what it all means. And project 2, you do some more of these basic static things with a different one. Lab 1.2 with virus total. This one's packed. So PEID will show you that it is UPX. So you have to unpack it. You have to go download the UPX unpacker and unpack it, which you can do on Windows or Linux. And then you can see that now it's Visual C++. And then you can analyze the same sort of things down here. So that's the first couple of projects. The first thing you got to do is get some VMs running. We've got them in the lab. Any questions about anything? All right, well, I'll go to the lab and help anybody that wants to work here. Most students prefer to work at home, which is fine. But